Hi, today we're going over second half of section 4.8, which is solving linear and quadratic inequalities graphically. Steps for solving linear inequalities are rearranged into slope-intercept form, also known as mx plus b. Plot y-intercept, use our slope to plot several other points, join the points with a line, and then use our graph to create a number line. So for example, solve graphically, 3x plus 1 is less than 5, and put the solution on a number line. So rearranging this, I'd move a 5 to the other side by adding 5 to both sides. So that gives us 3x plus 6 is greater than 0. So graphing that, we mark our y-intercept first. Because here we've got slope of positive 3. So we mark out our graph. And then we're looking for where graph is greater than 0. So in other words, where y value is greater than 0. We can see from this point this way, our y value is greater than 0. So our answer would be x is greater than -2. Now steps for solving quadratic inequalities. We move all terms to one side of the equation and then use your preferred quadratic graphing method, whether it's factoring and your x-intercepts or using your vertex form. We then use our graph to create a number line. So solve quadratic inequality, 2x squared minus 5 is greater than 1. So move everything to one side. So we have 2x squared. We'd subtract 1 from both sides. Minus 6 is greater than 0. So I can see I have a vertex. This is in vertex form. I see I have a vertex at 0, -6. And then from graphing parabolas, I know how to graph this. And then we'll just estimate where these cross. So let's say that it is 1.8 and -1.8. Now we can see from here this way, our value is greater than 0, and from here this way, our value is greater than 0. So we'll have two separate inequalities. We'll have x is less than -1.8 from this one, and then x is greater than 1.8 from this one. Now putting in a word question, the length of a rectangle is 2 meters longer than 3 times the width. The area of a rectangle is less than 44 meters squared. To the nearest tenth of a meter, what are the possible dimensions of a rectangle? So first thing is we will use our area formula, which is length times width. Now we know the area of a rectangle is less than 44 meters squared, so 44 is greater than what our length is. Our length is 3 times our width, which will say our width is x, so 3x plus 2 times x. Now rearranging this, I'd move the 44 to the other side. I would also FOIL this out. So I've got 0 is greater than 3x times x is 3x squared. Then 3x times 2, so plus 6x minus 44. Now a key thing for this is we need to know where our x-intercepts are. So I'll use my quadratic formula. So negative b plus or minus square root of b squared minus 4ac, I'll divide by 2a. So we've got negative 6 plus or minus square root of 6 squared minus 4 times our a value of 3 times our c value of negative 44 over 2 times our a value of 3. Now from this, we get 3.5 and negative 4.2. Now, because our a value is positive, we know it's going to be opening up. Now, because it's asking where this equation is less than 0, we're actually looking at this center section here. So to write out that this is our answer, we're going to say that x is between negative 4.2 and 3.5. Okay, practice work for a section is found on page 355, numbers 3 to 7, 9, 11, and 12.